Hi there. For this video, we'll be talking about the binomial theorem. So let's write that one down. Binomial theorem. So the binomial theorem states that if we have x plus y raised to n, this is equal to the summation from k equals 0 to n, and we have n choose k times x raised to n minus k times y raised to k. Now note that if you don't know or haven't encountered combinatorics, this one out here is equal to n factorial all over k factorial times n minus k factorial. So this theorem is really helpful, especially in cases wherein we need to find, say, x plus y cubed or even higher, raised to 5, and so on. So let's have some examples. Let's first have the trivial example, which is x plus y raised to 1. So our goal is to arrive with simply x plus y, since x plus y raised to 1 is simply x plus y. And so applying the theorem, we have the summation from k equals 0 up until 1, the combination 1 choose k and x raised to 1 minus k and y raised to k. So this one is equal to, first we have at k equals 0, we have 1 choose 0 times x raised to 1 minus 0, or simply 1, and y raised to 0 plus at k equals 1, this is 1 choose 1 times x raised to 1 minus 1, or x raised to 0, and y raised to 1. So this one out here represents the k equals 0 part, and this one out here represents the k equals 1 part. So let's simplify this one. First, this one out here is equal to 1 factorial all over 1 factorial times 1 minus 0 factorial. Since these are just a bunch of 1s, this will simply be equal to 1. So we can replace this one out here into 1. On the other hand, this one out here, we can write this one as 1 factorial all over 1 factorial times 1 minus 1 factorial. And since these are still a bunch of 1s, indeed 1 factorial is equal to 1, 1 factorial is equal to 1, and 1 minus 1 is equal to 0, and 0 factorial is equal to 1. So take note of that. So this one also becomes 1. Now furthermore, y raised to 0 will always be equal to 1, and x raised to 0 will always be equal to 1. And so this one simply simplifies into x raised to 1 plus y raised to 1, or simply x plus y. And so we have arrived with our expected outcome, which is this one. Now I will leave to you as an exercise the x plus y squared one, and verify this, that this one is equal to x squared plus 2xy plus y squared, as we know in the square of a binomial, or the previous video. So let's move on to x plus y cubed. So this one is equal to the summation from k equals 0 up until 3 of 3 choose k times x raised to 3 minus k times y raised to k. And so we have, at k equals 0, we have 3 choose 0, x raised to 3 minus 0, or simply 3, and y raised to 0, plus at k equals 1, we have 3 choose 1 of x raised to 3 minus 1, which is 2, times y raised to 1, plus 3 choose 2 of x raised to 3 minus 2, which is 1, times y raised to 2. So let's move this one first, since we are lacking in space. Plus 3 choose 3 of x raised to 3 minus 3, or x raised to 0, 0 there, and y raised to 3. So let's simplify this one. First, note that all of this with exponent 0 is simply equal to 1. So we can remove that 1 out here. And let's adjust this one. Also, these exponents out here with exponent, these variables with exponent 1 is simply itself, which is y raised to 1 is equal to y, and x raised to 1 is equal to x. So we can remove the exponent out here. Let's focus now on these one. Note that we can write this one as 3 factorial all over 3 factorial times 3 minus 0 factorial. This should be 0 factorial. Since, let's put it out here. The formula is n factorial over k factorial times n minus k factorial. So this one simplifies into, again, 0 factorial is equal to 1. So this one becomes 3 factorial all over 3 factorial, which is simply 1. So this one becomes 1. Moving further, this one out here, you can write this one as 3 factorial all over 1 factorial times 3 minus 1 factorial, which becomes 1 factorial is simply 1. So this becomes 3 factorial all over 3 minus 1, which is 2 factorial. And we can write 3 factorial as 3 times 2 factorial all over 2 factorial. Cancelling out the 2 out here, we obtain 3. So let's write that one down. Now you can verify that 3 choose 2 out here is actually equal to 3 as well. So let's remove that one. And also, 3 choose 3 out here is actually just equal to 1. So we can replace this 1 with 1. And so we obtain 1x cubed is simply x cubed plus 3x squared y plus 3xy squared plus y cubed. And that is the answer for this one. And as an exercise, let's clear this one out first. As an exercise, you may try to attempt to obtain x plus y raised to 4 by applying the binomial theorem. This will give us summation from k equals 0 up to 4 of 4 choose k of x raised to 4 minus k times y raised to k. And you can do the math in solving this one by applying the same idea that we did in the previous examples. So yeah, that's it for this video. You can practice this one out since this would be really helpful, especially in multiplying binomials. So that's it, and that is all for this video.